Alright guys, looking at today's lesson, we kind of already did a piece of this. We're going to look at determining if two lines are parallel or perpendicular or neither. And then we're going to learn to write equations for those. Now, what I'm going to do is we're going to really cover just the first 2 points here today. Tomorrow, or whenever we come back to school, okay, we're going to talk then about how to write the equation for perpendicular lines. So we're going to take this kind of slow today and looking at how to do the equations of parallel lines and how to do the equations of perpendicular lines. And we'll go from there. So when we look at this, I mean, you guys went on the Inspire activity, and what did you guys find out about the slopes of parallel lines?
They're equal.
They're the same, right? So that's really important. I want you guys to make sure you get that down. The slope of parallel lines are the same. The slope of parallel lines are the same. I cannot stress that enough. However, for perpendicular lines, they're not the same. And they have a very unique relationship. And that relationship for perpendicular lines is that they are, and I know it's hard to read that, they are negative reciprocals. Negative reciprocals. So what does that mean, to be a negative reciprocal? Gavin?
It means that the reciprocal means to flip it, like it would mean that if it's a -5, it would be +5 to the other line.
No, let's, you're close, you're very close. Let's say I had -2/3. So the reciprocal means to flip it, which means now I'm going to be dealing with the 3 over the 2. And what does the negative tell me to do?
Make it the opposite.
Make it the opposite sign. So if I'm starting with -2/3, my negative reciprocal slope would be positive 3 over 2. And there we go. So if I have one line with a slope of -2/3 and another line with a slope of 3/2, those two lines must therefore be perpendicular. They're negative reciprocal slopes. So when we think about our first objective for today, determining if two lines are parallel, perpendicular, or neither, all you have to do is simply look at the slopes. You don't have to worry about looking at the y-intercept. All you have to do is look at the slope. So again, if they are parallel, they have the same slope. If they're perpendicular, they are negative reciprocals. And neither. Well, neither is really easy. If they're simply intersecting, it means that they're not the same slope, and they're not negative reciprocals, therefore they're not plain old intersecting lines. So let's practice this. Here we go. Notice that not all of these are put in slope-intercept form. So you might have to think a little bit.
Number 1's parallel.
I want you guys to look those over. You might have to take a very close look at these.
I have a question.
Yes, Danielle. Just ask your
I
question.
can't
Why?
because
I'm going to ask you later.
well, I can't figure this out then. I don't know.
Y equals mx plus b. Okay? So that gives you the slope.
All right, so hey, the first one. If I have y equals 2x plus 4 and y equals 2x minus 10, what are my lines? Definitely parallel. Very good. Looking at the second one, y equals -1/2 x minus 12. Y equals 2x plus 7. Tommy, what'd you get for that one? It's going to be perpendicular. All right, on the third one, y equals 3x plus 19. Y equals -1/3 x minus 9. Keanu.
What? Oh, perpendicular.
Perpendicular, very good. All right, down here, 6x minus y equals 15. X plus 3y equals -10. Now, guys, you got to be careful here. If it's not in slope-intercept form, what do you have to do?
Put it in slope.
Put it in slope-intercept form. So you have to solve for y. So when we do that and we look at that bottom row, Ted, what do we get for that first one there on the bottom?
Y.
Okay, are they parallel, perpendicular, or neither?
Neither.
Yeah, that's right, they're neither. Okay, they're just intersecting. If I look at the next one, 9x plus 3y equals 6, and 3x plus 9y equals 6. So Ashley, what do you think?
I'm not sure.
Okay, well, let's try this. If we're not really sure, what we can probably do is put those into slope-intercept form. So if I take my 9x plus 3y equals 6, and I want to solve for y, I want to move my 9x over, so negative 9x plus 6, and then divide everything by 3, I get negative 3x plus 2. Okay, so that's my top equation. My bottom equation, we're going to do exactly the same thing. So I'm going to move my 3x over, so 9y equals negative 3x plus 6. Divide everything by 9, and I get negative 1/3 x plus 2/3. So again, all we're looking at is just the slopes. So are we parallel, perpendicular, or neither, actually? Perpendicular. And I'm going to say you're really close on this one. We definitely understand those are reciprocals, right? But are they negative reciprocals? No, so in that case they're just intersecting, so neither. That one's a little tricky. Alright, and then the last one. Justin. Okay, why do you say that?
Looks like it's the negative reciprocal.
Well, if we solve the top equation up there, right, if we take 3x plus 2y equals negative 5, and I put that in slope-intercept form, I get 2y is negative 3x minus 5, and therefore y is negative 3/2 x minus 5. And so when I consider that slope with this slope, they should be, well, no, they're the same slope, therefore parallel. So that's our first objective today. You're going to be able to look at the equation of two lines and determine if they're parallel, perpendicular, or neither. And so I think we've got lots of practice with that. Remember, parallel, same slope. Perpendicular is negative reciprocal. Okay, and if it doesn't fill in one of those two categories, it's neither. And I think the textbook might call that intersecting but not perpendicular. But that's basically what the neither means. It means you're neither parallel nor perpendicular. Alright, so with that objective done, let's get into writing the equation of